Welcome viewers. In this video, we'll see the Ohm's law, definition, limitations and problems. First we'll see the Ohm's law. The Ohm's law states that current flowing through the electric circuit is proportional to the potential difference across the circuit and inversely proportional to the resistance of the circuit, then provided temperature remain constant. So what is the statement given? The current flowing through the circuit is directly proportional to potential difference across the circuit and inversely proportional to resistance of the circuit. I is directly proportional to V by R, directly proportional to potential, inversely proportional to resistance. So by cross multiplying this, we can write V equal to IR. That is a very basic formula in electrical. Voltage equal to current into resistance. Based on the Ohm's law, what we got? V equal to I into R. The important thing is the temperature remain constant. Because when the temperature changes, the resistivity, current, everything will change. So based on the condition temperature remain constant, then only this I equal to V by R, so that V equal to I into R. So temperature remain constant. Now we'll see the power expression for power from this Ohm's law. V equal to IR. The power is nothing but V into I, voltage into current. V into I, the power, we know that power equal to voltage into current. But based on the Ohm's law, what is V equal to IR? We will substitute this V equal to IR. So that power equal to IR into I. This V is replaced by IR. Then this I is written. So what will happen? I square R. So power can be expressed in a new formula is called I square R. The general formula is V into I. The V is substituted with IR. So that what we got? I square R. So the power in terms of current is nothing but I square R. Generally it is called as a power loss. Because the loss is depends upon the current, so this term is normally referred as a power loss. And one more expression, power equal to V into I, but based on the Ohm's law, V equal to IR, I equal to V by R. Now we'll substitute I equal to V by R. Previously we substituted V equal to IR. V is replaced. Now we will replace I. So I equal to V by R. So that power equal to V into I is nothing but V by R. So that V square by R. So another formula for power is in terms of voltage is V square by R. So we got two different expression for power. So this is a general expression, voltage into current. This expression based on current and resistance, I square R. This expression based on voltage and resistance, V square by R. So three different formula available based on our requirement, based on the data, we can use either any of this formula. Now we'll go to the limitations. What are the limitations of Ohm's law? The Ohm's law does not apply to all metallic, non-metallic conductors. So it is applicable only metallic conductors. Non-metallic conductors is not applicable. We cannot apply the Ohm's law to non-metallic conductors. It also does not apply to non-linear devices. Only applicable for linear devices. Linear devices mean when current increases, voltage also increases linearly. But in non-linear devices, we cannot apply the Ohm's law. The example is Zener diode. We cannot apply Zener diode. For non-linear devices, we cannot apply the Ohm's law. The third one, Ohm's law is true for metal conductors at constant temperature. We already discussed, if temperature changes, a voltage, current, everything property will change. So we cannot apply the Ohm's law. Only when the temperature is constant, then only we can apply the Ohm's law. If temperature changes, the law is not applicable. We cannot apply the Ohm's law. Right? So it is applicable only metal conductors under the constant temperature. Non-metal conductor is not possible. Non-linear device also not possible. So these are all the limitations of the Ohm's law. Now we'll see the resistance, resistivity. One more term is available, resistivity. We'll see now. We'll see this resistance. What are the property of the resistance? Resistance of a metallic conductor depends upon the following. The resistance of any metallic conductor having this following properties. One is directly proportional to length of the conductor. The resistance is directly proportional to length of the conductor. If length increases, the resistance also increases. It is inversely proportional to cross-sectional area of the conductor. The cross-sectional area, it is inversely proportional. When the cross-sectional area increases, resistance will decrease. And this depends upon the nature of the conductor. It depends upon the nature of the material of the conductor. Depends upon the material, the own property of the material. And it is depends upon the temperature of the conductor that we already discussed. Resistance is Ohm's law is applicable only constant temperature. So it is depends upon temperature also. So based on the above statement, it is clear that R is directly proportional to L by A. Directly proportional to length of the conductor, inversely proportional to area of the conductor. So while equating, we are introducing one constant called rho. Rho is nothing but resistivity. That is depends upon the nature of the material of the conductor. It is given by the manufacturer. Resistivity. One more term is called a resistivity. So that R equal to rho L by A. So we can find the resistance based on these three parameters. Resistivity, length of the conductor, area of the conductor. So this resistivity depends upon the material, nature of the material. So similar to resistivity, we have conductance. Resistance like that, the inverse one is the conductance. Resistance means opposing the flow of current. Conductance means it is allow the current to flow in the conductor. So the conductance G, the term is G. Conductance is the inducement to the flow of current. Hence conductance is the reciprocal of resistance. Resistance will oppose the flow of current, but conductance will inducement to the flow of current. So both are inversely proportional, reciprocal. Both are reciprocal. So G equal to 1 by R. Resistance, this is conductance. So now we discuss the resistance in terms of resistivity and conductance. Now we'll go for a problem. We'll solve three different problems. We'll see the first problem, problem 1. The resistance of a conductor 1 millimeter square in cross-sectional area and 20 meter long is 0.346 ohm. The resistance of the conductor is given 0.346. The area of cross-section is 1 millimeter square. Then length is 20 meter. Determine the specific resistance of a conducting material, that is resistivity. We need to find the resistivity, right? The resistance, cross-sectional area, length is given. We need to find the resistivity. So first we'll convert the given data into meter. So area equal to 1 millimeter square. In order to convert into meter square, 10 to the power minus 3. Meter to millimeter to meter mean 10 to the power minus 3. Here meter square is there, millimeter square. So 10 to the power minus 6 meter square. So 1 into 10 to the power minus 6. So the millimeter square is converted into meter square. The length is 20 meter. Is already given in meter. The resistance is 0.346 ohm. These three data are available. So what we need to find? The resistivity. How will you find the resistivity? The formula available. R equal to rho L by A. Just now we discussed. R equal to rho L by A. So cross multiply this. R into A equal to rho L. Bring the L in the denominator. R A by L equal to rho. That is rho equal to R A by L. So from this formula, all these values are known. So we can find the rho. So it is rearranged in such a way that rho equal to R A by L. Now we can substitute the value of this R, A and L. R is 0.346. A is 1 into 10 to the power minus 6. The length is 20 meter. So by simplifying, what we got? 0.0173 into 10 to the power minus 6 ohm meter. The unit for resistivity is ohm meter. 0.0173 into 10 to the power minus 6. So we will move the decimal into two places, so that 1.73 into 10 to the power minus 8 ohm meter. Right? The decimal is moved to two places, so that this 10 to the power minus 6 become minus 8. This value increases means power also increases. 1.73 into 10 to the power minus 8 ohm meter. Right? So this very simple problem. In this formula, R is available, L is available, A is available, so that easily we can find the rho resistivity. Right? Now we'll go to the second problem. The second problem is the electric heater draws 80 ampere from 250 voltage supply. When electric heater is there, it will take the 8 amperes from the supply 250 voltage. What is the power rating? And also find the resistance of the heater element. Two questions we need to find. What is the power rating and what is the resistance of the heating element? So the given data, the current is drawn by is 8 ampere. Supply voltage 250 amperes. So these two data are available. Supply voltage and the current. What is the power rating? Power rating is nothing but V into I. Voltage into current. Voltage is 250, current is 8 ampere, so 2000 watts. The power rating of the heater is 2000 watts. V into I. What is the resistance R? R equal to V by I. Based on Ohm's law, V equal to IR. So R equal to V by I. V is 250, I is 8. So 250 by 8, 31.25 ohm. Is 31.2. The resistance of the heater element is 31.25 ohm. Right? So we calculated power rating as well as resistance of the heater element. Now we'll go to the next problem. We'll refer the third problem. What will be the current drawn by the lamp rated 250 voltage 40 watts connected to 230 volt supply? Right? So the one lamp is available. The rating of the lamp is 250 watts 250 volt 40 watts. We need to find what is the current taken by this lamp. It is connected across 230 volt. Since this 250 is the rating, this 230 is the supply voltage. It is connected across 230 voltage. Right? So what are the data available? Rated power is 40 watts. Rated voltage is 250 watts. Supply voltage is 230 watts, 230 volt. Now we'll find the what is the question. We need to find what is the current taken by the lamp. In order to find the current, first we will find the resistance R. R equal to V square by P, because the power is available. What is the formula relating power and resistance? Just to now be discussed. V equal to power equal to V into I, one formula. I square R, another formula. V square by R, another formula. So here V and P is available, so that we can use this formula. P equal to V square by R. From that R equal to V square by P. So V is 250 square divided by power rating 40. So that 1562.5 ohm. Right? From the given data, power and voltage, we calculated the resistance of the lamp is 1562.5 ohm. Right? So the power P equal to V square by R. From that R equal to V square by P. So now we got the value of current, resistance. Already supply voltage is available. So from this R and V, we can easily calculate the current. Current I equal to V by R. V is already given. Supply voltage 230. 250 is the rated voltage, but supply voltage only 250. Resistance now we calculated 1562.5 ohm. So we can substitute here. V equal to 230, R equal to 1562.5, so that 0.1472 amperes. So the current drawn by the lamp is 0.1472 ampere, right? So in this problem, power and voltage is given. From that we calculated the resistance. From the resistance we calculated the current drawn by the lamp. Now we'll go to the next problem. So the fourth problem is, a battery has an EMF of 12.8 voltage and supply a current of 3.24 ampere. One battery is available. The EMF of the battery is 12.8 voltage and current is 3.24 amperes. What is the resistance of the circuit? We need to find what is the resistance. How many coulomb leaves the battery in 5 minutes? How many coulombs leaves the battery in 5 minutes? The two questions we need to find, right? So what are the data available? The battery EMF is given, V equal to 12.8 voltage, and current is given 3.24 ampere. 3.24 ampere, the current is given, and time also given, 5 minutes. 5 minutes means 5 into 60 seconds. Converting into 6 seconds, we need to multiply 60. So the resistance can be easily calculated. R equal to V by I. The formula is there, R equal to V by I. That is V equal to IR. From that, R equal to V by I. Both are given. Voltage, EMF is given 12.8. Current is given 3.24 ohm. So this 12.8 by 3.24, what we got? 4 ohm. The resistance of the circuit is 4 ohm. And what is the charge leaving the battery? Charge is nothing but current into time in seconds. Current is 3.24. Time is 5 seconds, 5 minutes. 5 into 60 is a second, converted into seconds. So 5 into 60. 972 coulomb. So the charge leaving the battery in 5 minutes is 972 coulomb, right? So in this problem, voltage, current and time is given. From that we calculated the resistance, voltage by current, and we calculated the charge using the formula current into time, right? That is 4 ohm, this is 972 coulomb. So in this video we discuss about the Ohm's law, what is the definition and what is the formula. Then power in terms of resistance, V square R, I square by R, 2 times. Then limitations of Ohm's law. Then resistance, what are the property of the resistance. In this the important thing, resistivity. We discuss about the resistivity. The resistance means the reciprocal conductance, that also we discuss, and we discuss the 4 problem based on this Ohm's law. Thank you.